Okay guys, we should have watched those Ed Rollo videos, but I'm going to try to recap reasonably quickly and go through a couple of exam questions to help you out as well. So we are doing 14A, which is binomial distributions, and we can use binomial distributions when we have these three things here. So the random experiment has to have two outcomes only, so one might be success, one might be failure. The experiment is repeated a number of times, so it could be 2, it could be 100, it doesn't matter, and the trials have to be independent of one another. So let's just think about rolling a dice. So with rolling a dice, there are actually 6 outcomes, but you can make it have only 2. So if we want to roll a dice and get a 6, one outcome could be getting a 6, the other outcome could be not getting a 6. Okay, so you can make certain events have 2 outcomes rather than more than that. If we're rolling that dice and trying to get a 6, maybe we might be rolling it 10 times. Okay, the question might say 10 times, might say 5, it doesn't matter. The last thing, the trials are independent of one another. Okay, so if I'm rolling that die and then I'm rolling it again next, the outcome of that first roll, it's not really impacting on that next one, is it? Okay, so they'd be independent of one another. If we had some scenario where we were maybe taking balls out of a bag and not replacing them, we wouldn't be able to use binomial because the experiment isn't exactly the same each time. Okay, because there would be a different number of balls in the bag. So it has to be the same thing, just repeated. Now, this is the rule that we're going to be using right here. Now, this section here, you might remember that from last year. This is combinations, so hopefully that's familiar. The guy in the Ed Rollo video spoke about it a little bit. If you're not too sure, you might have to go back and have a look at that. We'll see that there's some different letters in here. So there's an X, N, and a P. So this is what each of those mean. N means the number of trials. So if we're rolling a dice, how many times we're rolling that dice. X is the number of successes out of those trials. And P is the probability of success. Okay, now let's talk about what this rule is actually giving to us, which is this sentence down here. So it's going to tell us the probability of achieving a certain number of successes, X, if we have N number of trials. Okay, so if we're rolling the dice 10 times, what's the probability that out of those 10 rolls we get 5 successes? Okay, now we're going to do a really quick example right here. So this one says, what's the probability of rolling 2 6s if we roll a die 5 times? Now, a really smart thing to do to start with would be to write all of these things down. So number of trials, number of successes we're after, and also the probability of a success. So N is the number of trials. In this example here, we're rolling the die 5 times. So that's the number of trials. The next one, number of successes. So rolling a 6 would be a success. We're interested in rolling 2 of those. So X would be 2. And P is the probability of success. So rolling a 6 would be 1/6. Awesome, so there's some important information that we need. All we need to do now is get these numbers and pop them into our formula to work out the probability of achieving 2 6s if we roll the die 5 times. So I'm going to write that into my formula here. The probability of 2 6s, 5 trials, 2 successes. P is the probability of success, which is 1/6. And we're having 2 successes, so that's the power of 2. And this next part here is the number of failures. So 1 minus the probability of failure. So 1 minus P would give us the probability of failure, which is 5/6. And we need the number of failures here. So if we're having 2 successes out of 5 rolls, that means there's going to be 3 failures. So something that we need to make sure works is these 2 numbers. They should add up to make the number of trials. And these 2 numbers here, they should always add up to make 1. Okay, now we sometimes can do this by hand. I'm going to do this one mainly by hand. Alright, so 5 choose 2, that's going to give you 10. Again, go back to combinations for that one. This will give us 1 on 36, and this will give us 125 on, what is it, 216? Cool, and if we times all those ones together, we're going to get 625 on 3888. Cool, so that's going to approximate to something like 0.1608. Awesome. So if we wanted to do this same sort of thing, except we wanted the probability of rolling 3 6s instead of 2, we just need to change that x to 2, which is going to change some of the other numbers around here. But we can find out the probability of however many successes, 0, 1, 2, 3, 4, or 5. We're going to really quickly use our CAS to do that now though, because it can be super fast using our CAS. So we've got our CAS. We want to solve that same problem using our CAS. So we're going to go to menu to start with. Probability is our topic, so we'll go on to that. The next thing we're going to do is distributions. Remember, we are looking at binomial probability distribution. That's what the exercise is called. So we need to go down and find binomial, because that's what we need. There we go, binomial PDF, so binomial probability distribution. You'll see there's a CDF here as well. That's not what we want at the moment, but we will look at that soon. We want binomial PDF. Okay, so N was the number of trials. We wanted to roll the dice 5 times. The probability of success was 1/6. And the X value we want, so the number of successes we want, is 2. Cool, so hopefully we can see that that is the same probability as what we found out before, but how fast was that? Something I'm going to show you as well is, let me go back to where we were before. Alright, so again we had 5 trials, the chance of success was 1/6. You'll see how the X value here, it says optional. If you don't put anything in there, like we put in there 2 last time and it told us the probability of 2 successes, if we put nothing in there, it's going to tell us the probability of all those number of successes. So this first number here, that's the probability of 0 successes. This next number here is the probability of 1 success. The next one would be 2 successes, and so on and so on. So it could be a good idea to do that if you're asked for multiple. Could make it a little bit quicker. So let's have a quick look at a couple of exam questions now. So this one we'll start with. So a fair coin is tossed 12 times. So from that we already know what our N value is. We're tossing that coin 12 times. And it's a fair coin. So the chance of success is going to be 1/2. We just need X now, but let's have a look at this next line. So the probability, correct to 4 decimal places, that at most 4 heads are obtained. So it says at most 4 heads are obtained. So that would mean that when we are actually looking for the probability that X is less than or equal to 4, because that's what at most 4 means, doesn't it? Now this is slightly different because with that last question that we looked at, we were looking at a specific number of successes. So we're after 2 successes. This one's talking about 4 or less. So the probability of 4 or less would have to be the probability that we get 0, because that fits in that criteria, plus the probability that we get 1, that also fits, and also 2, 3, and 4 fit too. Oops. Cool. So to find out this, we'd sort of need all of these, wouldn't we? Now, I don't particularly want to do what I did just before 5 different times. Okay, now this is where the CDF comes in that we saw in our CAS, because this is cumulative, isn't it? We're adding 0 to 1 to 2 to 3 to 4. Okay, so this one is cumulative. So let's go into our CAS and work out how to get through. Right, similar steps as before: menu, probability, distributions, but this time binomial CDF, because we're accumulating here. So CDF, now the number of trials that we had was 12. We were tossing that coin 12 times. The probability of success each time was 1/2. Now you'll see these bits here are a little bit different. Okay, so we've got a lower bound and an upper bound. Now the lowest number of successes that we were happy with was 0, and the highest was 4, because remember it wanted the probability of 4 or less successes. And press OK, and there's our answer, 0.1938. It wanted the answer as 4 decimal places, which would mean that the answer is C. Right, this is the last question I'll look at today. Let's read through it first. So Harry's a soccer player who practiced penalty kicks many times each day. Each time Harry takes a penalty kick, the probability that he scores a goal is 0.7, independent of any other penalty kick. One day, Harry took 20 penalty kicks. Now, let's look at our information there. Hopefully we can recognise that this is going to be binomial. Remember those 3 dot points that I had? We need to have independent trials of each other, so whatever happens in one trial doesn't impact the next one. That's true here. We need to have 2 outcomes, so a success or failure. In this case, it's scores a goal or doesn't score a goal, and that kind of situation has to be repeated. So we can see here it's being repeated 20 times. Now let's look at this next section. Given that, okay, so we've seen this given that language. Hopefully what's coming into our head now is that this is a bit of conditional probability. So given that he scores at least 12 goals, the probability that Harry scores exactly 15 goals is closest to. Alright, so given that's going to change our sample space, isn't it? So down the bottom of our fraction, he has to score at least 12 goals. So down the bottom of our fraction is going to be the probability that he scores at least 12. So that will be greater than or equal to 12. So given that he does that, what's the probability that he scores exactly 15? So up the top would be the probability that he scores exactly 15. So from those 2 questions that we looked at a little bit earlier, hopefully we can see that this one here is going to be PDF. This one here is going to be CDF because it's cumulative. Now again, this is a multiple choice exam question, which means it's in exam 2, so you can use your CAS. Let's go straight to our CAS. So let's start off our fraction on here. No, I don't need that. Alright, now down the bottom of our fraction, which we had written before, was we wanted the probability that we had 12 or more successes, or 12 or more goals scored out of the 20 trials. So let's put that into this section here to start with. So remember, menu, probability, distributions, this one's cumulative, so CDF. We was having 20 shots, the chance of success was 0.7. We wanted 12 or more, so that would be 12 up to 20. I don't know why that came up. We're going to keep going. And up the top, we want to have the probability that he gets exactly 15. So exactly 15 would mean PDF, because it's a specific number. So binomial PDF. We were having 20 trials. His chance of success was 0.7, and we wanted the probability of 15 successes exactly. Cool. So our answer there should be 0.2017, which is E.